So when last we left this, I had just set up OSPF routing between these three devices and established the neighbor relationships that you see in front of you. Let's see, 31.3, which is say router 3, is in the full state. It is the DR, the designated router. 22 is the BDR, and 11 is the DR other, which is to say it is not in a position to take control of this multi-access Ethernet grouping unless both of the others fall off the network. If 33 drops, say for example, if I turn off its interface, then 22 and 11 will work amongst themselves. 22 will become the new DR, and 11 will actually become I think it will become the BDR. Anyway, so what we're going to do now is we're going to change this, completely rearrange this, because right now router 3 here is our DR, and router 1 is not. But if we go into the interfaces, in interface mode, and we change the priorities on these interfaces, that will change the math, and when we clear the OSPF process, that will all flip over. But just for giggles and grins, let's go in here. What I'm going to do is I'm going to shut all of I'm going to shut the loop back down, and then shut gig 0001 down, and we're going to watch what happens with these other two. Okay. Actually, let me move this over just a little bit more. Give you a little bit more room. Yes. So, I shut the loop back down, and I shut it down. Now, so these interfaces, these neighbor relationships drop off. And I'm going to do the same thing here. Now I'm going to do show IP OSPF neighbor again. And now, okay, 33 is the DR. Let's see. Okay, now it took a minute for those neighbor relationships to drop. Now let's look at neighbor relationships again. So 11 is the DR, is the BDR now. Now that took as much time as it did because, of course, your hold time is 40 seconds. So we've got 22. Router 2 is now our designated router, and router 1 is our BDR. Now, if I were to let's see if this works. I'll just do a no shutdown. Now I bring this interface up. Now let's see what its router ID is now. Do show IP profile. Okay, so my router ID is still on the loopback, whether it's up or not. So it may be that it is taking a minute while it's negotiating this interface here. There we go. Let's see if it comes back up. Okay, so what happens? It's in the init state, DR other. Okay, okay, notice I had router 3 was the DR. I dropped it off the network. Router 2, as the BDR, became the DR. Router 1, as the DR other, became the BDR. Now I put router 3 back on the network. It has the highest IP address, both in the subnet and on the basis of its loopback, but it's still the DR other because I haven't set the preempt flag yet. If I wanted to make sure that, now it's important to note that how the priority and preempt commands interact with each other. The preempt command will cause any given router, as it comes back up onto the network, to trigger a new DR election process. They actually, you'll see this in the debugs, they actually call it a coup. Not kidding there. What that preempt command will do is cause it to trigger an election. If you don't have it set up on the basis of its IP address or its MAC address or its priority to actually win that election, it will try to win, it'll trigger the election and then lose said election. So if you're going to set your preempt command, make sure that that other components of that configuration are also in line with it, so that it will not just preempt, trigger the coup, lose the election. A coup d'etat which doesn't result in a stable government, which usually is the case, most coup d'etats do not produce stable governments. And this is politics, not networking. But say, for example, the stuff that happens in South America or Africa on a regular basis, the changes in governments in banana republics and things like that. It's not a stable form of. If it can't produce a stable government, the coup is not a good idea. So when you're doing your preempt, make sure that it will actually do what you want it to do. So, but let's get back to this because I've kind of wandered off the goal of this lab. Let's actually move on to part 3 now. What we're going to do now is put in some priorities. So move this back over, and look at our. So we've done this. Now, part 3. I want you to, let's start by talking about this. Notice that on router 1, let's see, router 100, router 1 gig 1 has a priority of 255. Router 3 gig 1 has a priority of 100. Router 2 gig 00 has a priority of 0. And I realize I may have done this wrong on my... Oh, I did get this wrong. 0. Now, the result of all of this, and while I fix this, now, priority is a value that runs between 0 and 255. It's a single byte. Now, and on interfaces that don't need this, say for example serial lines, you'll see that the priority is always 0 because they don't need a DR election, they're not going to try to have one, so they set that value to 0. A priority value of 0 for OSPF for a DR election process ensures that that device is going to lose the election. It can't possibly win it. The default value is 1. The maximum possible value is 255. So, thinking about our configuration here, if I set my router 3 was, my router 3 was my BDR, my DR, when this all started. And actually, if I really want to make this interesting, actually, it's still going to be interesting. I was about to say, I could reset the OSPF processes on all 3 of these things right now before I do priority, and it'll go back to the way it was. Router 3 is your DR, 2 is your BDR, 1 is your DR other. We're about to flip that script because right now 2 is your DR, 1 is your BDR, 3 is other. The result of this configuration you've got on your screen right in front of you is that 1, with a priority that is as high as it can possibly be, will become the DR. 3, which has got a medium priority, will become the BDR. And 0 and 2, which has a priority of 0, can't possibly win the election. So it's going to go from being the DR to being DR other. So let's watch that happen. Okay, so I'm putting these in. Just because I put them in doesn't mean it will change everything immediately. The only way for something like this to change is if I bring all these interfaces down, bring them back up again, and then bring them back up again. So I suppose I could theoretically reboot the switch, which would break all three links. Everything would refresh, but that still wouldn't clear the OSPF process. The best way to do this is to clear the OSPF process. So 2. Let's make it 0. Boom. And 3. Give it copy 3. Okay, and notice that nothing is happening. So end clear IP OSPF process. Boom. Yes. And clear IP OSPF process. Boom. Yes. And one more time. End clear IP OSPF process. Yes. Okay, so the network will come down, it will come right back up again, and did that in no time flat. So now let's look at show IP OSPF. And I see that, okay, let's see. Okay, so I do not see my show IP protocols. I don't see it here either. Okay, so 22 is the DR other, as you would suggest. See, with a priority of 0. 33 is the BDR with a priority of 100. And now, let's just show IP OSPF interface. Okay, now, because unfortunately show IP OSPF interface brief doesn't work, let's see, in Packet Tracer, I have to do it this way. But in any case, I can see that I am the DR using, and I'm actually I'm using the 33.11 as my ID. I'm actually using the interface 1.1 to talk to that subnet. I can see my backup designated router and the interface that it's really using. I can see my hello timers. I can see all of it. It's not suppressing hello from any of its neighbors. Now, if I were to add another router to this mix, it would also fall in as a DR other. It would make its neighbor relationship to router 1. And if router 1 falls off the network, it would start talking to router 3. If I added another router to this subnet, and I lost router 1 and router 3, that new router 4 would become the DR, because router 2 can't possibly become my DR because it has a priority of 0. Let's actually look at it from the perspective of router 2 as well. Show IP. There we go. It is in the DR other state. It has a priority of 0, so it can't possibly win the election. Let's see, so we reset the process. Yeah, interface. Okay, so that's this lab in a nutshell. Have fun.